Hello class, today we're going to be going over lesson 3.2, connect representations of functions. So we talked about yesterday, we had some representations of functions, right? And what really do I mean by a representation of a function? What I mean is any way you can show a function. So yesterday we really focused on arrow diagrams, we focused on coordinates, like just x and y coordinates, and we focused on tables. Today what we're going to be focusing on is graphs. So let's talk about a few different types of functions. The first one I want to mention to you guys is a linear function. So let's think about what that word linear means. Well, what are the first four letters of it? Line, right? So a linear function is any function where the graph of your function appears to be a line, just a straight line. Now, the opposite of that is a nonlinear function. So a nonlinear function is still a function, except this time the graph of your function will not be a line. The graph might be curved, it might take turns, it really might do anything except for be a straight line. So if I'm helping you guys write out here, I would shorten these up a little bit. For a linear function, I would write line. Nonlinear, not a line. Now, another thing I want to talk to you guys about today is the vertical line test. And the vertical line test tells us if you can draw a vertical line on your graph and intersect your relation at most one point, then your relation is a function. So let's see, for example here. If I'm looking at this graph right here, and let's say we have the graph of the line y is equal to x, something like this. Now I can draw vertical lines down anywhere on my graph. And since my vertical line only intersects at just one point, this point right here, then yes, this will be a function because it passes the vertical line test. In mathematical terms, what I'm saying is each x value has exactly one y value. Now, a situation where this will not work is, let's say we got a function looking like this. This right here is a hyperbola. Now, if I'm drawing a vertical line on my hyperbola here, and I'm going straight down, excuse me, let me do that in blue. I've got my line going down right here. Notice how my vertical line intersects my my hyperbola, my graph, at 1, 2 spots. Since it intersects at 2 spots, this would not be a function because my x value has 2 different y value outputs. So this is not a function. Whereas this one right here is a function because each vertical line will intersect my graph at most one point. Alrighty, so let's get some visuals for you guys here. I wanted to show you some visuals of a linear and a nonlinear function. So on the left right here, we have a linear function. And the reason's simple, because it's a straight line, right? There's no curves, there's no edges, no sharp turns, no all of a sudden it's dipping down or something. It's just a very simple straight line. So that right there is a linear function. On the right-hand side, we have a nonlinear function. And the reason it's a nonlinear function is because of this point right here, this kind of area, what's going on. Notice how it looks like it's in a straight line, and then all of a sudden, whoa, we're making a little bit of a curve, right? Since we're curving like that, this would not be a function. It curves, it makes a turn. It's not a straight line. So that's a non-linear function. It's not a line. Alrighty, let's keep going forward here. So we want to use the formula for the area of a square to create a table and then graph a line. And then we're going to determine whether or not it's a function. So the area of a square formula can be found by doing area is equal to side squared. Now what that comes from is, you guys all know a square has all sides the same, right? And if I want to find the area of like a rectangle or a square, I multiply 2 sides together. So since a square has all the same side lengths, I could find the area of a square by doing side times side or side squared. The only way I'm going to change this formula right here is I'm going to change it to x is equal to y squared. So instead of a is equal to s squared, I'm just changing it to x is equal to y squared. So that way it can look like my x and y coordinates. Now I'm going to make myself a table here where I have my x values on the left and my y values on the right. So to make our table here, we need to plug in our x values, or my input values, and then we're going to find out what my output is. So if I plug in the number 0 for x, then, excuse me, I said this wrong over here. My apologies, guys. Y is equal to x squared. Not x is equal to y squared. Y is equal to x squared. I apologize. So if I plug in for x here, my x is 0. So I'll plug it in. 0 squared, or 0 times 0 is 0. Now how about 1? I have to plug that in for x. Y is equal to 1 squared, or 1 times 1. 1 times 1 is 1. How about 2? Y is equal to 2 squared. 2 times 2 is 4. Well, how about negative 1? Y is equal to negative 1 squared. Negative 1 times negative 1. Remember, a negative times a negative will give you a positive. Negative 1 squared is 1. How about negative 2? Well, negative 2 times negative 2 is 4. All right, now I have to go over here and graph these points. So my first coordinate is 0, 0. So I'll go to the coordinate 0, 0, or the origin, and make a dot. My next one is 1, 1. So I'll go over to my coordinates here. I'll go right 1 and up 1, and there's my new coordinate. I have another coordinate here, 2, 4. So I have to go right 2 and up 4. This right here is my new coordinate. Then I have negative 1, 1, again right here, and negative 2, 4 right here. And I'm given this graph. The graph y is equal to x squared. All right, so to determine whether or not it is a function, let's draw ourselves some vertical lines here. Notice how all of these vertical lines I'm drawing are going to intersect my graph at most 1 point, So since these vertical lines intersect my graph at most 1 point, that means every input has exactly one output, or yes, this is a function. All right, we got another question for us here. We want to determine whether these here are functions, whether each graph is a function. The way we're going to do it is just by drawing vertical lines. So let's start with this first graph here on the top left. Y is equal to the absolute value of x. So if I draw my line straight down, notice all of these lines are intersecting my graph at most 1 point. So since they're intersecting my graph at most 1 point, I could say yes, this one right here is a function. Well, how about this one over here? Again, drawing lines straight down, all of them, they're only intersecting at 1 point, right? They're only intersecting at 1 point, which means that this graph is indeed a function. This right here, yes, it is a function. Each one of my vertical lines intersects at most 1 point, meaning every input has exactly one output. However, let's see something different. How about right down here? Well, if I draw a vertical line, look how many times we intersected. I intersected 1, 2 times. My vertical line intersected my graph twice. So that means that x value had 2 y values, or my input had 2 outputs. So this would not be a function. Same with like right here. If I'm drawing my line straight down, I intersect at 1, 2 points. So this would not be a function. And for the last one, again, intersecting my graph at 1, 2 points. So this is not a function. Alrighty, everybody. So that was what we did today. We talked about different relations of functions, different relationships between functions. We talked about graphs and tables today, and we kind of talked about when something will or will not be a function. Remember, the vertical line test tells you if you draw a straight line down on your paper, or on your graph rather, that straight line can intersect your graph at most 1 point. If it intersects at more than 1 point, then it is not a function. So what I need from you guys now is 2 complete sentences about what you learned today. If you have any questions, I'd be happy to answer them in class tomorrow. Take care, everybody. Peace out.